Get a full screen. All right, so just going to add a few more problems here during the second half of the term. We'll start with some early algebra considerations. And hopefully these aren't going to be the most challenging problems that you've seen all term. So I've got a couple of linear equations written here. I hope that you would recognize that if I hadn't said it. Textbook generally calls this standard form, but I think I'm just going to refer to them as X and Y intercept form, just to highlight that that's how we use these. So I've got two numbers that subtract to a constant. So I just picked a couple of numbers. These do not work in this equation, but if they do, it's accidental. They certainly don't. 10 minus 4 is 6. We start with something we know is true. I'll make the X side a little bigger. Okay, going up by 2. In this case, I gotta go down by 2 to make the subtraction equal the same constant. So what do we learn from that? Well, if my x's get bigger and my y's get bigger, then I've got a function that's increasing. And for the same reason that this function's increasing, this one's decreasing. I've got two numbers that add up to a constant. If one of them gets bigger, which is actually moving from left to right, starting someplace and moving to the right, then the other is going down in order to maintain the constant. So the other is going down. So if you see an ax plus by equals c problem, then you know it's a linear function that's going down, and this one is a subtraction that's going up. And these are called systems of equations, and we can solve them using two methods. One's called elimination, and the other is called substitution. I don't think I did substitution on the video just before this one, but I did do elimination, at least talked about it. So, but let's get a perspective on where they intersect very quickly, just so that if a careless error is made, we can spot it, because very easy to make careless errors on this particular problem, because there's about, I don't know, 6, 8, 10 steps to getting an answer. None of them hard, but anytime you do 10 things computationally, it's easy to make a careless error, especially for me at my advanced age, and I tend to do things quickly. So 5x minus 3y equals 7 gets us our x-intercept, 7/5. So let's make a 1 here. Let's say that that's 1. 7/5 is just going to be a little bit bigger, 7/5. Y-intercept minus 7/3, which is a little more than -2. So there's 1, 1, 2, a little bit more, maybe right about there. And that's minus 7/3 for a y-intercept. And so I connect them, show a couple of arrows. All right, that's it. Line 1. Line 2, x equals 9. Well, x is over here. If that's 1, probably have to go even further. Probably out here somewhere, the x-axis. This is 9 for an x-intercept. And my y-intercept is 9/7, a little bit bigger than 1. That's 1, a little bit bigger, might be about here. And so what did I say that was? 9/7 for a y. Connect the dots. And I can see that these intersect in this vicinity. And you're certainly going to look for a positive x, a positive y, and not too big. And if I'm asking you in the second half, I'm going to have to figure out, maybe I'll give you the odd problems one day on Thursday for a test, and the even on Friday. So I would like you to overlearn this material, because it's no good to you if you don't remember it in a couple of years. When you get through your geometry course and then you're in algebra 2, got to remember this stuff. Not have to teach it again. So we're going to have to overlearn it. So I'll probably give you integer answers for the most part, so that you're not spending a lot of time on these 3 questions here. All right, so let's have at it. Let's go figure out if we got a small positive x and a small positive y. And so first method I prefer elimination. I do it a little bit differently than the textbook. I like to use a negative to, in this case, x plus 7y equals 9. I'm going to multiply by -5 because I prefer to add the columns than subtract. So -5 times 7 minus 35y, and -5 times 9 minus 45. Then when I add up that column, that eliminates. Minus 38y equals -38. Nice, simple. Y equals 1. Yep, that's a small positive y value. I can believe that, just maybe on an angle. Can you see this? Yes, I think I can replace that with a 1. Yep, that does appear to be about 1 unit high. And if I get a simple integer for an answer, then instead of doing elimination again, I'll just plug in y to the easier situation here. Let's plug in 1, so 7 times 1 is 7, and I can see that x is 2. Okay, and then, yeah, that looks like it's a small x positive and a small y. So that seems to be working out nicely. And I could have done substitution. So x plus 7y equals 9, which means x equals 9 minus 7y. So instead of x, I write the new name for x. The new name for x, 9 minus 7y, and you can see the calculation brings us to the same place. So 2 different methods, 3 ways to check that. Elimination, substitution, and graphical approximation. All right, so the next question, after I have my sip of coffee. Made a good cut. We've been doing perpendicular lines. So there's nothing new there. You know the negative reciprocal. Right, but instead of asking it, giving you the xy intercept form of an equation and finding the slope that way, solving for y, we're just going to practice solving slope a few days in a row. So we get good and quick at it. So 3 to 8 is change of 5 for y's, and 7 to 9 change of 2 for x. Why I wrote that. 2 for x. So we have a slope of 5 halves. And let's have it go through negative 7, 1. And if it's parallel lines have the same slope. Over up's the same. So therefore, we have y equals 5 halves, passing through negative 7, 1, x plus 7 plus 1. And if it's perpendicular, the negative reciprocal, which is minus 2/5. So the y perpendicular, I'll use that symbol for perpendicular right now. Minus 2/5. I want it to go through minus AB, then I go x plus A plus B, which is really what I did up here, yeah? Okay, so that's going to be quick and easy. A little quiz tomorrow on that, same question, not asking you to do anything other than look at the video and make sure that you've tried the problems. I'm assuming if you do that, you will get this. And the only way you won't is if you don't do it and practice. Y varies directly as x, and y equals k times x. As x gets bigger, y gets bigger if I'm multiplying by a constant. So I've given you an x and a y, 2 and a 10, 10 for y, 2 for x. Very easy to see that k is 5, which means we now have a new situation where we know the constant. So if I give you one or the other, you should be able to solve this with ease. I gave you y equals 30 equals 5 times what? X is 6. Okay. So you'll see that tomorrow, which means you just got to know that this is direct variation. As x gets bigger, we started with an x of 2. Our x then became 6. Yes, it's bigger. And y was 10 and it became 30. And I hope you can see that the constant of proportionality here is another fancy name for slope in this context. Then we have inverse variation. As x gets bigger, y gets smaller. So what do we have? We got solve for the constant of proportionality. Constant spelled with a K, K-O-N-S-T-A-N-T. My grandson thinks cat is spelled C-A-T. I keep correcting him, K-A-T. All right, so plug in the numbers given, 2 for x, 10 for y, 10 for y, 2 for x, find the constant of proportionality. I think we can see that k is 20. And then we're going to rewrite this again and use the eraser. Inverse variation. So right now over here we have an x. That's what did we start with? 2 gave us 10. X is going to get bigger, y is going to get smaller, and we're going to see it happen right before our eyes. I don't have an eraser with me, unfortunately. So I'm going to go y equals 30. Constant is 20. One variable equation. So 30x equals 20. So therefore x is 2/3. Looks like 2/3 is smaller than 2, but What did I say? Y is 30 is bigger than 10. Sure looks like inverse variation here. Yep, now you can see it. X has got smaller, Y has got bigger. And we call that inverse variation, fancy name for inverse change. And then combination of the two of direct and inverse, making it a little more complicated. And, we can get ourselves some nice science problems generating from this. But right now, let's just get the mathematical process down. So if Z varies directly as X, Z varies directly as X, right? There's multiplication, and inversely as Y squared. That's how you would write what you need to write in order to solve this. So I got a 16 for X. So I got a 16K. I'm going to solve for the constant K, K-A-T cat, of proportionality. So I'm substituting 16 for X. I'm substituting 2 squared, Y squared, 2 squared, and that's going to equal 12. Let's divide that so we can see where we're working. So 4 times 12 is 48, equals 16 times K. Division becomes multiplication, and so it looks like K is 3. So what do we do now? We set it up again. I'll use it right here. Save myself some time. If Z is 3, okay, I got Z is 3, X is 4, times 4. And we just solved for Y, which is 3. We solved for K, K is 3. And so now I have 3Y squared equals 12 over Y, 3Y squared equals 12. So Y squared equals 4. And we'll just say Y is 2 for now. And I'll do a little reading about getting those plus minus values. I'm assuming we're just going to work with the positive. But let me get back to you on that. I wasn't anticipating even thinking about that yet. So we're just going to take the one answer for our quiz tomorrow. All right. So that's that video. We've got 3 more problems that we're adding to our midterm exam, and our final exam will probably have about 100 to 110 questions, worth probably 120 to 130 points. So you got to keep up with things, and I'll add that to our worksheets, and we'll have at it again in a couple of days. Try to learn a couple of things every day. All right, so see you on Thursday. Let me stop that and the video.